drivers and how to get the documentation, and we also saw the demo software that you can download from the HID Global website, and also showed you how to read and write the SLE4442 tag. So in this video I'm going to show you how to do the same thing using my learning software, that understanding contact cards. For OmniKey 3121 you have to have the version 1.4, and if you have the software but if you don't have the reader writer, you can, or if you don't want to buy the reader writer, you still can get some knowledge out of this video, because I will be showing you how to use all these PCSE commands using this reader writer. And this is the document I mentioned in my previous video. So here you can see the software is running. I've connected my 3121 here, and I'm going to hit the get readers. So you're going to see this the name of the reader as OmniKey Cardman 3x210. Now the same software also works with the ACS 39X, and what I have done inside the software is I'm checking the name OmniKey, and this name or this word is going to decide the functionalities in the software. And before I continue, I would like to mention this: most of the commands in ACR 39U and OmniKey, more or less they are same. It's just one or two commands they're different, probably I will mention in this video. Now if I hit the connect, before it's the connect, you have to insert. So I have inserted SLE4542 and click the connect. So this is the same screen you have seen in ACR 39X as well. The only thing, couple of buttons are missing. Now the card, okay, so first I'm going to get the ATR. The ATR, okay, is this string. You can use ATR to determine what type of card is inserted here. The ATR of SLE4442 is this one. Now if you look at the commands, this is just a Windows WinSCART command. The next thing I'm going to hit is the go. This is going to read all the 256 bytes from the memory, and the commands to do that is, it is the read memory. This is FFB. If you go to the documentation, the read binary is what I have used. You can see that this is the standard PCSE command, and this command is used to read more or less any RFID tags. It's FFB0, the 16 bits of address, and followed by the length. So if you look at the software, what I'm doing here is I'm reading the first 250 or something like that bytes here, because you cannot read the entire 256 bytes in one read command. Now this is the command starting from address 00. I read so many number of bytes. So this is actually 250 bytes F0, and after that the remaining 16 bytes I'm reading using one more command. It's the same read binary command, and if you notice here, all the response ends with 9000. So this is a standard, probably a kind of a ISO standard way of saying that the read is successful. Now for a new tag, the default memory values are all set to FFs, except now I've highlighted the first two lines here. This corresponds to the first 32 bytes, which has got the ATR. If you can see the A291, and followed by, this has got some manufacturer data. If you click on the chip data tab, so this basically decodes the information that is stored in the first two or the first 32 bytes. And the reason I'm showing you this in yellow color is, every byte here can be locked. So the locking is done, and if you look at my videos on SLE4542, I have mentioned that the SLE542 has got a separate memory to store the protection bits. So this is just a read operation. You can see that the same card we used in the demo software as well. Okay, next I'm going to show you how to write. Now we know that this tag SLE4452 needs a password before write, but let's try to write something and see what's going to happen. I'm going to put, say, D1. You can edit directly in the screen. D2. So we'll have D3, D4, D5, and hit the write button. Now the write is an error, so it's obvious that it has to be an error. If you look at the command, I have used this command ffd6 and followed by all the data and so on, and the response is 69 and 82. If you go to the document and look at, this is the one I have used, update binary, and it ffd6 followed by the address, and the length is 16 and the data. The write was not successful. We got 69 and 82, and this says the security status not satisfied. So this is exactly what it happened. No pin was presented. So that shows the write is not successful. Write is not possible without a successful pin. Now on the top section here, you have got 4 bytes, and these 4 bytes, they're called as a PSC bytes, and one of the byte is the error counter. The other 3 bytes are the actual password of the pin. So since it is a new card, the default value is the password as well. So the password is all FF. If I say authenticate, now the authenticate will return you back how many more chances we have got. It's 7. If you look at the command, I have used the command called verify. Now this is the command which is also mentioned in the document. The verify is clearly explained here. So this is the command you're going to use to verify the password with the SLE4442 or 4428, and here the pin length will be 3 followed by the pin. So we got a success 90. If you look at the output is 90, and it is authenticated. Now I can write. Now keep in mind the read doesn't need any authentication. So the write here, as you can see, it says success. Now the write is successful. Now I'm going to try out what happens when the password is not valid. So I'm going to take this tag out. Remember, the tag remembers the password. Okay, so connect, get ATR, click on a go. Now this is the data we have written. Now I'm going to make the password wrong. Say A1 and give authenticate, and you got, if you look at the response, we got 63 and C2. If you go to the documentation, this is exactly what we got. 63 and C2, and 2 here, the X is 2 we have got. It means we have got 2 more chances before the card completely locks out. Now I want to try again with the wrong password. Authenticate. So twice I've gone wrong. I don't want to try again because this card will be now completely locked. Look at that, you got C1, and I'm going to reset the password to FF and try authenticate. You got back this value 7. Now that's how the authentication works. The next thing here is about the changing the password. So to change the password, let's give it a try in a different way. So I'm going to change the password without authentication. I've not tried that, so I've always tried change the password after the authentication. So I'm going to change the password. So you have to send the old password and the new password. The software remembers the old password as soon as you authenticate, and for the very first time the old password is all FFs. So I'm going to change the password to A1 A2 A3 and hit change. So looks like the change worked. If you go back here, now this is the password. This is the command called change PSC. So the command I have used is, it's a not compare product, sorry, it's the modify command. So the modify command takes the old password followed by the new password. The length of, sorry, this will be 6, and this is the actual old and new password, and it's FF21, and I have said FF21. The old password is all FFs and new password is this. And let's try, I'm going to take this tag out. So I'm going to authenticate with a new password, A2 A3, authenticate. So authentication works. So you can change the password without first authenticating. This is something different from if you see my videos on the ACR39X, where it works in a different way. The next thing is about protecting this memory. Now protecting the memory does not work, or didn't work for me. So the way you protect the memory is you choose the address. This is the address here. You can't, the software doesn't let you tick here. Probably that would have been a nice feature to have. Now I'm going to choose the address 1 and say write, and this will again read the protected memory. Let's see what has happened here. So write protection bits. So the command I'm sending is FF30 followed by the address. Let me try. So this is called as a compare and protect. Yeah, the compare and protect, the command, it's something you just have to follow this syntax. So it says you have to send this information. So this is very, very, this depends on the way the firmware is written inside this device. So we have to follow this. So here, after the length is 5 plus n. This is the n is the 6 bytes. So here you got version 1 flag 00. Not very sure these flags are. It's not mentioned anything how exactly to use these commands. I just I'm sending this raw bytes as it is followed by the address, but the description says so this you have to send the value along with the command. If the value we send matches the value in the EEPROM, then the protection bit is permanently set. But however, if you look at the command, so I'm sending, if you look at this, we are trying to log byte number 1, which is the value of byte number 1 is 13. This is what the EEPROM has got, and I'm sending 13 as the value. This is the byte address, and all this information here, this is exactly what the documentation says. 01 followed by this address. Now I got a successful message here, but however it when I read back, this is supposed to read back, but nothing happened. I'm going to connect the ACR39U to show at least how to read this the log bits, or probably I can use my, I've got one more tag here. Let's try that. you hit this button, read button, you can see now there are so many cells that are red now. So they corresponds to the lock bits. If you look at the command, there is a separate command for read the protection bits. So this is the command with FF3A. If you see, that is FF3A. So followed by the how many bytes, I'm reading I know that there are 4 bytes in the protection memory. I'm reading all the 4 bytes, and this is the value of the 4 bytes. And when you decode this into binary bits, you end up having this data. So one thing, what we are not able to do with this OmniKey 3121 is to set the lock bit. So I have sent a ticket to OmniKey, and I'm waiting and say why, how this works. It's something to do probably with the command, the way something missing, I would think, the way I'm sending the command, it's not what the system wants. So finally, I'm going to give you a comparison between the OmniKey and ACR92U. So this software works with both reader writers. I've connected my ACR39U, and as you can see, there are 2 readers. I'm going to choose the first one, connect, and this is the difference between OmniKey and ACR. In ACR, you have to first do the select card operation, then you can get the read. All the things are more or less the same except few commands, which I'm going to show you now. And you can read this, the protection memory, and you can read and write. So you can write, say for example, I'm going to say A, B, C, D. So here I have been using only the write for the entire 16 bytes. So you can write for a single byte as well, which my software has not done that. So I give a write command. Now if you look at the write is okay. However, I'm not very sure why it is okay, because this is supposed to be, I think this is the difference, between the way ACR39U and this works. So the write looks okay. However, when you try to read it, you got back the old value. In fact, the write was not successful. Now that's the difference. In case of a OmniKey, if you try to write without authentication, you get an error. However, in case of ACR39U, the write will return the success code, but if you try to read the data back, you get the old data. Now these are some of the differences. Again, if you can compare the commands. I'm going to just open the ACR39U document as well. So these are the differences we have got. In OmniKey, the read protection memory command is FF3A followed by the address, whereas in case of the ACR, the read protection bit is FFB2. So it looks like these commands are not standard commands. These commands are either they are decoded within the firmware sitting here, or it could be in the driver. So the other difference is the write memory. The write memory in 39U is FFD0, whereas in case of the OmniKey, the write memory is a standard PCSC update binary command. It's FFD6, and here it is D0. So this is the command to write the protection bits. So here FFD1, whereas here, so update protection bits has a different command structure. Now there is a command for, look at this command for the presenting the password or the PIN. So here it is FF20, whereas here it is called as the verify command. We have seen that. So this is FF20. So here also is FF20. So probably these two command structures are same. Probably the parameter could be different. So sorry, that was a wrong chip. This is the SLE4442. So here the present the pin is FFB1, whereas here you got FF20. That's one difference as well. And reading the protection bits. So here, to read the protection bits, you got it's FF3A, whereas here it is FFB2. So apart from these differences in the bytes, so more or less you got every feature in both the reader writer, except just now we saw we're not able to protect the memory bytes.